Well, welcome everybody to today's webinar on how to use machine learning to predict Ethereum USD prices. Leading the discussion today are Jorge Torres, who is the CEO of MindsDB, and Nick Howard, who is the CEO of QuestDB. We have about 30 to 40 minutes of content plus demos, which will be about a 50-50 split, and time at the end we'll have for Q&A. Please feel free to introduce yourself in the Livestorm platform and use the chat to do so. Ask questions in the Q&A button, which is down on the right-hand side. We will moderate those at the end. And you can also use the react emoji during the presentation for things that you like. Let me hand it over to Nick.
Hello. I'm Nick, co-founder and CEO of QuestDB. Nice to meet you all. So I'm going to very quickly go through QuestDB. So what is QuestDB? It's a fast open source database for time series data. And essentially, we allow companies to store time series data efficiently and then perform real-time analytics with SQL. And what makes us unique is that we are focusing on performance, and we've built the entire database from the ground up in order to get there. So what does that mean for developers? First of all, high ingestion throughput. We can ingest more than 1 million rows per second. Two, we're optimized for timestamp data. So developers can search data by time very efficiently. And we use SQL to retrieve this data. And the performance, essentially, you can query billions of rows in milliseconds. And we've got a demo that we'll share later that does that. And finally, you can integrate with other tools, PostgreSQL, including, obviously, MindsDB and other popular tools like Grafana, Kafka, etc. So that's pretty much it from my side. I'll pass it to Jorge.
Thank you, Nick. We're super excited about this. A little bit about MindsDB. We started as an open source project back in 2017, and we went through Y Combinator as well. And it was a company that my co-founder and I started because we felt that machine learning could be simplified quite a lot for people that already had data in the database. And of all the MLOps lifecycle, there are so many different problems that actually make traditional machine learning difficult for the analyst and for the developer. It's complex, it's expensive, and actually there's a lot of problems as well into getting machine learning problems into production. And what we wanted to do was to democratize that by simplifying the whole process. If you think of the MLOps lifecycle, you have preparation, modeling, deployments. And we start with the intuition that perhaps doing the first step, the way that we learn machine learning is not the way that we should be applying machine learning. So most of the way that any of us that has learned machine learning learn it is when you do data preparation and modeling in Jupyter and using pandas to transform data, yet this data in a production setting or in an applied machine learning setting is likely to come from a database. And even if it doesn't come from a database, we'd be better off to pick a tool that does the job better. At the end, for instance, if the problem that we have is time series, it doesn't make sense for us to try to reinvent time series scripts on pandas. Anything that I can produce in a year's worth of time will shy away from all the work that the guys from QuestDB have developed over all this time that leverages on also like 20 years of database experience. So the intuition was, let's do and delegate data preparation to the databases. And if your problem is time series, pick QuestDB because that's the right choice. It does a lot of the things that you want to do and has some sugar syntax or syntax sugar to the SQL, so you can in one statement do things that otherwise will take you, a good number of lines of code if you're going to code them, and also quite a crazy amount of SQL if you're going to do it in a non-time series database like QuestDB. So data preparation, database, that's the right place. And then the second part was, okay, if you do the data preparation, you also want to do the modeling in a way that doesn't look like this one, where you have your data in the database. You have to do ETLing to wherever you want to actually train your models, run the scripts that you're doing your ETLing from, put those models into some wrapper for a web service, and then whenever you want to do a prediction, especially when it's time series, you need to go to the database, get the last n number of data points for whatever prediction that you want to do, pipe that to the machine learning model, expose that into results into some other application, or you may actually have to pipe that back into the data warehouse or data lake if you actually want to enrich data. So this back and forth of data, even when time series is a problem, becomes very, very complicated. Now, we thought, why don't we simplify the problem and we allow people to do the whole thing in SQL? So SQL in itself, again, being the lingua franca for databases, or for most databases, it's the right approach, we believe, and perhaps an abstraction that leverage on the fact that if you're doing data preparation in the database, then we can actually do the modeling in the database as well. So let's describe how that looks like in a very simple example. Imagine that you have, and this one is not time series, we'll jump into a time series one in a second, but imagine that you have a simple table, income and debt, and you want to actually ask databases for information about what you store in the database. And databases are designed to give you an answer if you hit some, whatever you have on your query statement hits a particular row that is stored in the database. So in this case, if you query for income equal 80,000, since we have a record that matches that, you get a result. The databases are not designed to give you an approximation. Yeah, and that's fine because that's not the purpose of a database. But even if the question that you have is very close to information that you already have, so say for instance, when 90,000, which is somewhere in between that data that you have, you could get an answer if you build a machine learning model. And in this case, a machine learning model will look very simple. It's a line that tries to fit the data that you have there. And the intuition that we had is, can we create, with a very similar syntax of that of creating a view, that line, and then query that line? So query anywhere within that surface. So the syntax is, again, similar to creating a view from another table, which is create predictor, and then however you want to name this predictor, and then from what you want to train. In this case, you want to train from the whole table, but you can now in this train from, you can leverage on all the data transformation capabilities that the database has. So if you want to manipulate this data, you can say train from and then select whatever select statement, and as crazy as you want the select statement to be. Now, the intuition here as well is that if your problem is time series, that select statement doesn't have to be even that crazy, because that's the work that QuestDB is doing or bringing for you to simplify the data transformation tasks that you have to do for time series problems. And then you specify the column that you want to predict. Now, if you're dangerous enough, you can also specify how you want the model to be built, how you want to encode the data. But from the get-go, MindsDB gives you an AutoML solution that does it for you, and then you can just kind of tweak as much as you want from it. We'll dive a little bit more deeper into this. But once you create that line, you can query it. You can actually say, okay, query on that line or that model the same way that you will query in a table, and then where the conditions on the where statement can be anywhere in between. Of course, data in the database is not that simple, but I hope that this intuition gives you the idea of the abstraction that we provide and we bring to the table, which is the ability to create models and to query models as if they were tables or views in a database. And this simplification summarizes the whole life cycle in a way that is actually very interesting. So let's describe this again and summarize it. The cool thing about doing it the way that we do it with MindsDB and QuestDB, oh, there's a logo there that's not refreshing, but anyway, with QuestDB and MindsDB is the data preparation on QuestDB, and then the modeling happens with that simple syntax that you have: create predictor from, and then you specify the query. And the cool thing is that deployment in databases, there's no concept of deployment of a table or a view. So the same thing happens with a model. As soon as you do create predictor, that thing is alive and you can query it right then, and you don't have to think of the MLOps lifecycle development part, because the same thing as you don't care as when you create a predictor, when you create a table, you can consume that table. The same thing happens to a model as a table. So all of a sudden, that simple syntax just summarizes the whole ML lifecycle. Now, of course, data in databases is a little bit more complicated than that. And the way that most people design data today, or data transactions today, is you don't want to lose historical information. So every time that you have some change, what you do is you insert a new row with whatever changes are happening and a new timestamp. So that way you have an archive of information because it's valuable. And that makes it so that most problems that people have in terms of applied machine learning when their data is in a database are time series problems. And that's when QuestDB really brings a lot of power to the mix. So imagine that in this particular kind of hypothetical scenario, that you are a data analyst for the Chicago Transit Authority, and you want to optimize the number of buses that you put in each route. And the problem that you have is that every day routes some routes can be very volatile. There may be construction going on, or there might be events that are kind of changing the dynamics of the routes in itself. Or also, like on a weekend, the number of buses that you need may be over than the ones that you actually have to do throughout the week. Purely, your problem here is you don't want the buses to be overcrowded, and you also want the buses to be empty. And there are so many routes in Chicago that you can just not simply guess. And there's a lot of volatility as you were to analyze like each particular route. So you want to leverage all the information that you have. In this case, you want to leverage the fact that every day for a given route, the number of writes that the route provides changes. And you want to leverage the history that you have to predict the future. Now, this problem is difficult because it's not just a single variable that you want to take into account. Say, for instance, you also want to take into account the type of events that are going on that given particular route and that given day. And you may actually have information about some traffic, et cetera, and you actually also have a problem that is that you don't have a single route. So this is a high cardinality problem. You have thousands of routes. And if you were to solve this problem in the traditional approach, you will train a model for each particular route, but that is unviable to put into production because you're not going to maintain 1,000 or 2,000 different models. So this problem is where you have high degrees of cardinality and they're multivariate and time series can be solved with MindsDB. And now imagine that the resolution that you had for each particular route was not by day, but by second or by hour, but you actually want to make the forecast by day. That's when QuestDB brings a lot of power to the table, because then you can do this type of aggregations in one simple syntax. The best way for us to summarize this, let's go into like a live demo. And I know live demos sometimes can be a disaster, but let's pray to the demo gods. And we're going to walk you through a demo of how to glue these two things together, QuestDB and MindsDB, for a time series problem, which I think many of you are going to love because it has to do with forecasting cryptocurrencies, which I bet a lot of people want. So let's jump into that. I hope you guys can see my screen, but MindsDB can be accessed by any MySQL client or anything that speaks the MySQL wire protocol, but also ships with a ID for you to run queries if you don't want to go and connect to it. But think of MindsDB as a database that speaks the same MySQL wire protocol, and therefore any tool that can connect to a MySQL database can do it. And then MindsDB can connect to databases. And actually, the objective here is that we don't reinvent anything that a database can do. So any query that you send to MindsDB that has to do with the data will be forwarded to the underlying database. So the way to connect to QuestDB is a very similar syntax that the one that you have to create a database with a different engine. So here we're saying, okay, I want to connect to a database, and I'm going to name this the QuestDB data source. The engine is going to be QuestDB. The parameters for this ones are going to be this. This is a demo server, and people can play with this. I assume that that's something that we're going to leave up for people to play around as well. So I already connected this, but so this data already exists. But the idea here is MindsDB aggregates data or collects the data that it needs for machine learning by connecting to a third database. And the purpose of that MLOps lifecycle that we described is that you pick the database that suits your problem. And if it's time series, I bet it's QuestDB. Now, this particular database already has some demo data. And let's look at the information that we have there. First, I'm going to show you. Oh, 1 second. Like that. So the way that you do this in MindsDB is by routing with the dot notation of the name of the integration that you gave, or the name of the database that you brought in, and then the table that you have on the other side. So this particular server has information about crypto trades for many different assets. We're going to specialize this demo on the Ethereum to USD. And as you can see here, there are different data points that we have with a 1 second resolution. So every second, this data gets updated, and you have the price at this time. So we have sell and buy. So let's look at both of those. Actually, let me just remove this so you can see. So yeah, you have buy and sell transactions, and you have a resolution of roughly a second on each one of those. And what we want to do is we want to take all of this information to train a predictor that will learn how to predict the actual price given the historical information that we have. Now, here's where the ML lifecycle gets simplified into one single statement. This thing that you have here is data preparation. And again, anything that you can run on the database, you can actually run here. And therefore, let's try to summarize that you want to create a model, you want to forecast the price of Ethereum to US dollars, and you have data in the database. So if you have data in the database, then you can leverage any query that you want. Of course, this one is by second. There's a syntax for you to summarize the sampling for like an hour and whatnot. The team on QuestDB has already prepared like a table as well with like resolution of 1 hour. Let me look into this one, which is the same information, but now aggregated by hour. And we're going to train both predictors. So if you want to forecast by hour, by day, by month, then you can do it in very simple statements. But let's train our first predictor, which is going to leverage on all the information that we have by second. So this is this query. You want to name this predictor crypto demo. And here is where it becomes interesting in terms of time series. You want to predict price. You want to predict the particular asset that you want to do is the site. So essentially, you want to group either by sell or by buy. And you want to do a prediction that takes into account the last 30 rows, and you want to predict the next 10 rows in advance. Now, let's run this predictor. Now, this will take a little bit, but MindsDB behind the scenes does all the AutoML that you need to do this. You can specify how you want this predictor to happen. Let me show you the predictors that I have. For the sake of this demo, I've already trained a predictor so that we don't have to wait until this finished training. So I did a pre-demo predictor. And let's describe this predictor. So what MindsDB will try to do is it will try to predict the actual value that you have and build a model this way. Sorry. So since we didn't specify anything, the AutoML engine goes and looks into the data set that you provided, which is whatever it was in this query here. And it will try to analyze what is the best way to handle this in terms of machine learning terms. So it looks at the data and it sees that there's a column called price. And since it's a time series problem, it's going to encode this information as an array of data using a numeric encoder. What it's saying is like, I'm going to encode with a numerical encoder each of the different elements that you have in that window of time, and I'm going to create an array of that information. Yeah. Now, the other thing that it sees is, okay, well, there's another variable called side, and it's a binary encoder purely because you only have two values. You have either buy or sell. And then there is amount, which is the actual value that you want to forecast. Here, the text that is a numeric encoder. You can change this. Let's say if you wanted to like train it only in the positive domains, and there's no negative amounts. Actually, here the AutoML made an assumption, but you could even optimize this. You can say, okay, positive numeric encoder, and then it will only take positive values for the amount. Then you have the timestamp, which is the variable that we're ordering by this data. And here MindsDB is saying, well, I'm actually going to encode this with an array. And in each one of those, I'm going to put the dates that we have. Now, the last thing that it does is I'm going to build a model. I'm going to build a model that takes the encoded variables of each of those columns, and I'm going to see which one performs better. So here it's saying the model is going to be the best one of either a neural network, a light GBM array, or SK-time, which is another library for time series. And then we can see which one of those performs the best. So let's look into this. So MindsDB trained those three models, and the one that performed the best was the LightGBM array. Now, since that model is already trained, you can actually query that model as if it was a table. The cool thing, though, is that you can join that model with the data that you have, so it can take the information that it needs for the historical data from whatever you have on the left-hand side of the join. So here we're saying, okay, I'm going to join my predictor, and I'm going to join it with the data that exists in the data source that I have, which is the QuestDB data source, table traits, and I want to predict for timestamp greater than latest. So essentially, it's going to try to go and look at the very frontier of your data and try to make the forecast given the information that it has in the last 30 rows of that, and predict the following ones. So here's the way that we're going to do it. And there you have it. Just like magic, it's going to give you, if you were to look at the timestamps, these timestamps don't exist on the database itself, and it's actually generating, the following. What did we tell it to predict? Yeah, the following 10, and there you have it. Forecasting on time series, one single statement to create a predictor, and then a very simple statement to actually do the joining of the information that you have with the predictor that you have to forecast in the future. For the sake of this demo, and while we continue with the rest of finalize the slides, let's train another one, but now by hour. So we're going to use the table that does the aggregation by hour, and we can leave that training. I'm going to stop sharing for now and go back to the main slides. Okay, Dave, do you want to cover this one?
We've actually got a number of questions in the chat and the Q&A. So maybe let's do some Q&A first. And while we're putting those together, let me just kind of go over, for attendees to this webinar, there have been a number of questions about how do I get started, how do I get going? So we've got two offers for you. The first one from the MindsDB side, if you go to cloud.mindsdb.com, you can start up with a free account, you can sign up there. We have a community both in Git and Slack. The links will be here in the presentation that we'll send afterwards. And for those who star us on GitHub, we've got some nice cool swag for you. From the QuestDB side, they're also providing some good swag, and they also is a demo in terms of the data set that's actually available on demo.questdb.io. And so please feel free to head there, and you can get access to a lot of this data. Let me just jump to the questions. There are several that are here. The first one I'll go through from a not answered perspective. Let me see. So from Mikhail, the question is, can this approach be used in multi-resolution environments like video analysis with depth coloring?
Wow. So I have never worked on that problem myself. But if you can store some of that data in the database, then I think it will be possible. You will need probably like a video encoder, which you can build, and people have like encoders for images and things like that. But I actually don't know. Maybe the best way for us to proceed here is, if you want to reach us through Slack, then we can dive into how you want to tackle this problem, and then we can either help you build an encoder for the video part, or we can even jump into building it with you. But as it is right now, we don't have any video encoders ourselves.
The next question is, what ML libraries are used behind MindsDB, and how do I bring my own model? And what is a way to customize that model? And I think you might have touched on some of that, Jorge, but maybe you could talk about that.
Yeah, so you can bring your own model by third-party tools that allow you to deploy models in a very organized way, like MLflow or Resurf. And MindsDB integrates with them in a way such that you can bring those models to tables and then join that information with data that you have in, say, QuestDB. And that integration is something that now is stable, and you can actually check out on documentation. I'll put the link in the chat for you guys.
The next question here in the Q&A is, what happens with database performance when ML models are trained?
What happens with ML performance when what?
With the database performance. So is there any impact to the database in terms of when we're training ML models?
Yeah, so the other thing that we wanted to do by design here is to allow the machine learning workloads to run in a separate node. I mean, you can install them both, QuestDB and MindsDB, in the same server. But what we wanted to do here was to give you the flexibility of how you deploy this. And MindsDB in itself runs as a separate server to QuestDB and to your database. And therefore, any machine learning workloads only consume from the database whatever queries they need to run on the database for getting the data. So if your data is, let's say, for instance, you're transforming data and you're changing the resolution from 1 second to a month, whatever it takes the database to run those queries is what MindsDB utilizes from the database. But again, that is the type of optimization that that QuestDB is bringing to the table. So at the end, it is what is meant for. Now, on the other hand, the model execution and the model training and all of that runs on the MindsDB node.
Yep. We had a question in the chat, which is, have you thought about also to provide an explainer values such as SHAP, S-H-A-P?
Yeah, that's a great question. So we have in the past brought up SHAP values and kind of like importance metrics. We're actually adding some of that back again into the graphical user interface. But long story short, we're still understanding what is the best way for us to provide explainability features to the user in a way that they can manipulate those pieces of information themselves, rather than us building those visualizations internally in the GUI. But if this is something that you're interested in, I will encourage you to join our community, and then we can design this together, because we've tried this in different approaches, and we still haven't decided what is the one that we're going to marry to.
This is maybe related, but is MindsDB checking the source data on bias before training the models?
Yeah, that's a great question. So we believe that data ownership and bias ownership are the things that that the person that owns the data should be responsible and accountable for. In terms of what is coming for the next release, we have some visualizations about the distributions on the data and some kind of highlights as to what may be some potential bias that you may have. Yet, I think that bias in data is such an important element to any machine learning task that it shouldn't be the call of the machine to kind of ignore biases or kind of like do its own auto behavior, but depending on some bias detection. But it should be more of a job of highlighting when there is some potential biases. And yeah, that's something that it is coming for the next release. We had that on the first version of MindsDB. It's just that the graphical interface was overcomplicated, and we're trying to simplify that part.
Another question from the chat: is there a free online course to learn more about MindsDB and QuestDB?
I can very quickly answer this one. So obviously we have the documentation, which includes a lot. Also have introductory videos on YouTube. Perhaps that could help on our channel. Yeah, that is what we have, and obviously a lot of tutorials where you can build applications with QuestDB at its core, step by step. Those are the resources I would recommend to go to as a starter.
And Jorge, do we have anything like that for MindsDB?
So we have the documentation docs at mindsdb.com, but I think that we also have some articles that we've written in the past on how to do time series and MindsDB, so we can try to summarize this on the materials that people can get after this.
Great. Couple more questions in the chat. Can MindsDB handle NLP workloads?
Yeah, that's a great question. So we can handle input variables that are text, and also categorical and long short text. We are in the process of, or we have an integration right now that is rapidly evolving, which is the integration to Hugging Face. So any of the transformers that exist on Hugging Face, you can bring into the mix. So yeah, we do support NLP, and now we're also taking the approach of, there are frameworks out there that do it very well. We just want to bring that capability to the data layer. And the first one of that nature is the integration with Hugging Face.
Alrighty. Last question I think I can see, so I'll give people back a little time here, is since it is all SQL syntax, can forecasting be visualized in various BI tools?
Yeah, so we were on the alpha release of all the things that we needed to fix to be able to visualize this on Tableau. But there are other BI tools that are more compatible with MindsDB. Again, it speaks SQL, it speaks to MySQL wire protocol, so you can connect to MindsDB directly from those tools. It's just that some of the statements that this BI tool sends to MindsDB were not supported until the version that we have in alpha. So in the next like 2-3 weeks, the release that you guys will see out will have full support for BI tool and alike. And it comes with a caveat. We've tested a few of those BI tools, but if you have one in mind, again, the invitation here is join the community, and we can help you crack any issues that you may have on trying to see this visualization. Again, the cool thing here is, I don't know if you guys have played out with QuestDB ID as well, but when it comes to time series, it comes already with like some really cool ways to visualize your time series data right there. So I will invite everyone to go and explore that part too.
Yeah, fantastic. Well, I think we've kind of come to the end of the questions. I don't see any more in the chat. I think they're all answered. So let me just say on behalf of MindsDB and QuestDB, thank you everyone for attending today's webinar. Please keep in mind there is, go and check us out on both GitHub for the stars to basically get some swag. You can create free accounts on clouds.mindsdb.com, as well as see the demos on QuestDB, so demo.questdb.io, and the respective presentation and the script that you will see will be available shortly after we finish this recording. So thanks everyone for attending, and we'll catch you later.
Thank you.
Thanks all.